is the reaction between tetrachloroaurate and copper producing gold chloride ion and the copper 2 plus ion. So first thing that we need to do is to identify which of these elements involved in the reaction undergoes changes in the oxidation number. So here chlorine is -1 and then gold is +3. This is 0. Gold is 0, chlorine is -1, and copper is +2. So we can see that gold has a decrease in the oxidation number, meaning it lost electrons, it gained electrons, so it undergoes reduction. And copper goes from 0 to +2, so there is an increase in the oxidation number, meaning there is a loss of electrons. It undergoes oxidation. So meaning the reaction in the anode, which is the oxidation half reaction, is the loss of electrons by copper. So copper solid to copper 2 plus, that's AQ. And then meaning this is 2 negative. So do not include the coefficients written in the overall nga equation because, diba, as we know, these are put here to balance the equation. So there's 1 copper and 1 copper on the right, and the total charge on the left is 0, so we add 2 electrons to balance the charge on the left. And then for the reaction of the cathode, which is the reduction half reaction, so that's AU Cl4 negative AQ, and then we have AU solid plus Cl negative AQ. So we need to balance the number of atoms. So AU is only 1. Therefore, chlorine here on the left. So we put a coefficient of 4 on the right. So the total charge of the reaction, the portion on the right side is -4, but it's only -1 here on the left. So to balance the charge, we add 3 electrons on the left. So diba mo follow lang gid siya nga ang electron i-add sa right kung oxidation, ang electron i-add sa left kung reduction. And so, because this is 2 and this is 3, so that explains nga kanidi ay nga equation atong i-multiply of 3, so that explains the coefficient here nga 3. And we multiply the second equation by 2 to make the number of electrons 6. So, munang na 2 diri, nya na 2 ni siya, nya na 4 ni siya. Okay, so these are the reactions, half reactions occurring in each half cell. So this time we are going to draw the diagram. I mean the galvanic cell. So we have the anode half cell and the cathode half cell. And so we have our anode is copper na solid, and our cathode is this is gold, AU. And so they're connected an external circuit with a voltmeter attached to it, and then the electrons flow from the copper anode towards the gold nga cathode. So there is a solution here. So when copper undergoes oxidation, it loses electrons producing Cu2+, and the Au Cl4 negative in the solution goes to the cathode to receive the electrons to form gold. So the copper anode will be used up, and the gold nga cathode kay mo baga. Okay, and of course we must not forget that there is a salt bridge here connecting. So you can just you don't have to specify kung unsay ionic substance nga na diha, so you can just write nga ang cations will go to the cathode and the anions will go to the anode to balance the charge. Alright, and so in writing the cell notation, so the cell notation is, so for the cell notation, so we have copper on the left, that's solid, and it undergoes oxidation to produce Cu2 plus AQ. So lahi-lahi siya nga phase, so we use a single vertical line and then 2 vertical lines to represent the salt bridge, and then we have Au Cl4 negative, that's in a solution, and then we use a single vertical line producing Au nga solid. And then the question now is, ma'am, ngano asa man padung ang chlorine? So we did not include chlorine in the cell notation because it didn't undergo any changes in the oxidation number. So you can just, so it's a spectator ion, so you don't have to put it in the cell notation. So diba negative 1 siya niya, negative 1 ra gihapon. So wala siya ni take part sa reaction. So it's a spectator ion. So this is our cell notation for the given reaction in the given galvanic cell.